All right, our next example is this expression. First thing, get this denominator factored. It is partial fractions because we have polynomial divided by polynomial. The degree of the numerator is smaller. Partial fractions. Polynomial divided by polynomial. Degree of the numerator is smaller. That's the thing you want to use partial fractions with. Get this denominator factored. First, factor out the x, and then you have to FOIL this thing out. And I think if you do that, I have this written here. Let's go ahead and cut to the chase scene. That becomes x times x minus 1 times x plus 3. Is that, yeah, that looks about right. All right, and dx. All right. So that's the factoring. So this is category 1 because this is distinct linear factors. So the partial fraction decomposition is we have negative 5x minus 3 over this expression. There's an a over the x plus don't know yet over the x minus 1 plus don't know yet over the x plus 3. Now when you do this process, these coefficients could be anything. They can be decimal, they can be fraction, they can be negative, they can be and they could be 0. We don't know yet what those coefficients are going to become. So trust the procedure to carry you through and just work the algebra. The algebra carries you through this. All right? So the next piece is we're going to multiply both sides of this equation by this common denominator. This gets multiplied on both sides of the equation. On the left-hand side, when you multiply this expression, x times x minus 1 times x plus 3, here, all three of those cancel with all three of those. And so, as always, this is always the case. On the left-hand side, you inherit this numerator. Category 1, 2, 3, 4, doesn't matter. On the left-hand side, you inherit this numerator. On the right-hand side, you need to be careful. When you distribute these three factors to this first term, do you see what cancels? Yes, this x cancels with that x, and you're left with a times the x minus 1 and the x plus 3. Don't worry about multiplying that out. All right? When you multiply this times the middle term on the right-hand side, the x minus 1's cancel, and you're left with the x, and you're left with the x plus 3. And then same song, next stanza. When you multiply this denominator times this last fraction, the x plus 3's cancel, and you're left with the x and the x minus 1. So this is straightforward. You do this 4 or 5 times, it follows the same path every time. It starts to become familiar, and it starts to get kind of into your comfort zone. All right? We have created the basic equation, which is true for all possible choices of x. If you want to, you can use x to be 114, but that's not going to be very helpful. What helps is to choose a value of x that makes these factors equal to 0. All right? And it doesn't matter what order you do them in. So, I might as well start with 1. So let's let x equal 1. If x is 1, put that in everywhere you see an x, substitute a 1. Good news is a bunch of this drops out. Because on the left-hand side, this is negative 5 times 1 minus 3. We'll figure that here in a minute. When x is 1, this term becomes 0. 0 times anything, that term drops out. Yeah? When x is 1, this term does not drop out. So we do need to work with the middle here. So when x is 1, we have b times x is 1. And this is 1 plus 3. I'll just write 4. And here, when I plug x equal 1 into here, when x is 1, this term becomes 0. This factor becomes 0. This term drops out. And so that's all that survives this process. Each time you let x equal 1, in category 1, let x equal each of these values, 2 of them fall out, 1 remain. And so in this case, what do we have? We have, this implies negative 8 is equal to b times 4, and that implies b is equal to -2. All right, so we know what that coefficient is. Now, let x equal -3. If x is -3, I'm going to go ahead and do this all together. -5 times -3, right? -5 times -3 is 15. Positive 15 minus 3 is 12. When x is -3, that goes to 0, so this falls out. When x is -3, that goes to 0, so this falls out. When x is -3, we got some work to do over here. This is c times -3 times -3 minus 1 is -4. So I have 12 is equal to c times 12. That implies that c is equal to 1. And now we have that, right? We have b is -2, we have c is 1. So we've let x equal 1, we've let x equal -3. I think their other choice is let x be 0. If I choose x to be 0, then what happens? This is going to fall out, this is going to fall out, that's going to give me a solution. So, choose a value that causes one of these factors to be 0. If x is equal to 0, we have -3 on the left-hand side. If x is equal to 0, this is a times -1 times 3. When x is equal to 0, this falls out. When x is equal to 0, that falls out. And so I have -3 is equal to a times -3. So a is equal to 1. So we have b, we have c, we have a, we have all three coefficients for the partial fractions. And I'm going to run out of space here. So I'm going to write this as, what was a? A is, where's my number? A is 1. 1 over x plus, where's b? B is negative. Again, write this as plus -2. Try not to get in the habit of writing it as -2. You'll see why here in a bit. -2 over, what was that? That was over x minus 1. And what was c? C was 1. I'll see if I can squeeze this in over here. There, I think I'm all there. And so we've replaced this expression with its partial fraction decomposition. That's 3 form. This is now something you can handle because each of those is a natural log form. It's natural log absolute x for the first term is plus 2 natural log absolute x minus 1 for the second, plus natural log absolute x plus 3, and the constant. Anytime you extend the line, you put the plus and you carry on just extending the line over because I ran out of space. So there we go. That's, again, category 1, distinct linear factors for partial fraction decomposition.